Question is, two identical circular coils P and Q, each of radius R, carrying currents 1 ampere and root 3 ampere respectively, are placed concentrically or perpendicular to each other, lying in the xy and yz planes. Find the magnitude and direction of the net magnetic field at the center of the coils. Given in the question, P is placed along the xy plane and Q is the coil which is placed in the yz plane. So I is equal to 1 ampere, that is the current flowing across P coil, and I is equal to root 3 ampere, that is the current flowing across Q coil. So as per the questions, okay, Rp which is equal to Rq which is equal to R, and Ip, current across the coil P is 1 ampere, current across the coil Q is root 3 ampere. Here we are going to calculate the magnetic field due to the coil Bp. Then we are going to calculate the magnetic field due to the coil BQ at a common center O. And then we are going to calculate the net magnetic field. So first we are going to calculate the magnetic field at P. So magnitude of magnetic field at a common center O due to the current flowing in coil P is, so it is BP, which is equal to mu naught IP divided by 2RP. Substitute the values. So mu naught into 1 ampere divided by 2 into Rp and Rq, which is, it is the radius, so it is R itself. So BP will be is equal to mu naught divided by 2R. Similarly, magnitude of magnetic field due to the current flowing in coil Q is BQ, which is equal to mu naught IQ divided by 2RQ, which is equal to mu naught into root 3 divided by 2R. Here you have to note down the direction of BP is perpendicular to the plane of the coil P. Similarly, the direction of Q is perpendicular to the direction of coil Q. Therefore, the magnitude of resultant field B is equal to root of BP square plus BQ square, which is equal to BP is mu naught divided by 2R whole square plus mu naught root 3 divided by 2R whole square. So I am taking mu naught by R as a common factor, mu naught by 2R as a common factor, the square root of 1 square plus root 3 whole square. So what do we get here? Mu naught divided by 2R root of 1 plus 3. 1 plus 3 gives you what? Mu naught root 4. 1 plus 3 is root 4. Root 4 divided by. So mu naught root 4 divided by 2R. So root 4 is, you can write it as mu naught 2 divided by 2R. So 2 will get cancelled. So it will be mu naught divided by R. We know that the direction of BP is perpendicular to the plane of P and direction of Q is perpendicular to the plane of Q. So that is BQ is along the x-axis and BP along the y-axis. So the direction of the resultant magnetic field subtends at an angle beta from the direction of BQ can be calculated as tan beta, which is equal to BP divided by BQ. But what is BP? Mu naught divided by 2R whole thing divided by mu naught root 3 divided by 2R. So what we get here? Mu naught by 2R, mu naught by 2R will get cancelled. So it will be 1 divided by root 3. but that is tan beta is 1 by root 3. Beta will be is equal to tan inverse of 1 divided by root 3. So when tan theta can be 1 divided by root 3. When theta is equal to 30 degrees. So 30 degrees. So this angle beta will be is equal to 30 degree with respect to the x axis.